New tonight on Evening Plus, whooping cough has been around for decades. It's not a new infection, but a recent uptick in cases has scientists at Michigan State University looking to expand the current vaccine and what it's able to do. I sat down with one of those scientists, Dr. Shifei Huang. Here's our interview.
Whooping cough, it's something that many of us never have to interact with, but it is something that, still happens for some folks. If people aren't familiar with what whooping cough looks like, explain, if you fall ill with whooping cough, what does that entail?
Yeah, sure. So whooping cough is a disease caused by infection by bacteria. It's called Bordetella pertussis. So the symptom when people get infected, it takes about a week for them to develop symptom. And the symptom is a severe cough. They cough really, really hard. And when they cough like that, it make a whooping sound. And that's why it's called a whooping cough. It's been very difficult to recover from that. And another name for the whooping cough is called a 100-day cough. And it's because sometimes literally the patient can cough for 100 days. So
Wow.
it's a pretty serious problem. And it's particularly serious in infants and young children. The majority of people die from whooping cough infection are actually infants.
Mm. Yeah, and so I mean, it's not just a cough. This can be a really serious, potentially deadly infection that someone can get.
Absolutely, absolutely. Can develop, I mean, it's not just the coughing, you're absolutely right. And then can develop into a fatal disease that people die from the infection that way.
And we have a vaccine that's been around for many years, many people vaccinated against it. People know the basics of how a vaccination works, but as far as the science behind the specific current whooping cough vaccine, what does that work to do?
Yeah, sure. So, in general, though, the idea of a vaccine is we will administer vaccine to people, and what a vaccine does in the body is to boost our immune system, generate our immune system, and get our immune system to be ready to fight for bacterial infection when it comes around next time. So the current vaccine is, well, it may maybe give a little bit history about the whooping cough vaccine. Whooping
Hmm.
cough actually it was leading cause for death for young infant in the U.S., right? And in the earlier last century, hundreds of thousands kids die per
Mm.
year from whooping cough, right? But nowadays we barely hear about it, and thank goodness a lot of us don't experience that infection. It's because we have very effective vaccines. So in the 1940s, the first generation vaccine, whooping cough vaccine, came out. The doctors kill the bacteria. They kill the Bordetella pertussis and use that to vaccinate people. And as soon as they started doing that, you can see the whooping cough case just drop precipitously. So the vaccine worked very well. The problem for the first generation is that it also has side effects because they're injecting, even though it's dead bacteria, but there are a lot of bacterial components in there that cause quite a bit of side effects.
Mm.
And then when the infection rate become lower, and it's a risk benefit analysis, right? And when the risk become higher than compared to the benefits, and then the doctor thinking about research coming out about second generation vaccine. The second generation vaccine come about in the 1990s, early 2000s. What the researchers have developed is they would take specific component from the bacteria that make us feel bad, that
Mm.
we call the toxins coming from the bacteria. They use that. They don't use the whole bacteria anymore. They use those toxins, specific toxins, deactivate it so it's not toxic to people, right? But it has all this essential component in it. They use that as the vaccine. That's the current vaccine right now. That's generation two. So
And is that less side effects, I guess, than generation one?
yeah, absolutely. So that has much less side effects. So that's the good thing. The downside for that is now because you're just using specific component, you don't have the whole bacteria. The protection tend not to last as long
Mm.
as the first generation. Another challenge, and that's partially why we see the whooping cough start to come back recently in the States, is because this newer second generation vaccine they target this factors that make us feel not good, right? They don't directly kill the bacteria. So a
Mm.
person can still be infected with the bacteria. They don't have the symptoms, don't feel bad, but they carry that around. So the
Mm.
problem for that is that they can potentially pass this to infants or kids or people who are immunocompromised, susceptible to infections. So that's a problem. And when that happens, and also that gives the bacteria a chance to evolve
Mm.
to become more contagious. Yeah. So This is believed to be maybe perhaps part of the reason why in the past 3 or 4 years, since COVID, in the US, we have seen a significant rise in the number of whooping cough cases.
Mm,
Even compared to 2021, we have about 15-fold increase in the country.
wow.
So this is a serious problem that we need to get ahead of that curve, right? And hopefully we can continue to keep the cases down that way.
And just one clarifying question for you. So, right now, the vaccine that most people have, like they, even if they get whooping cough, they're not necessarily going to deal with all of the symptoms. They're very likely, going to be fine, even if they contract the virus. But then, passing it to people who may not have had the vaccine yet, or immunocompromised, or, older people, for example. And so I know that's where kind of the research ties in that you guys are doing now, I guess, of a potentially third generation of the vaccine, and kind of a different approach to how it would work. Can you walk me through that?
Yeah, absolutely. So yeah, you're exactly right. The current problem with the second generation, they don't directly kill the bacteria. Our immune system won't kill the bacteria directly, right? So what we are thinking about is, can we develop a newer vaccine, next generation vaccine that can target bacteria directly, kill the bacteria? So what we are targeting is actually, interestingly, bacterial cells similar to our human cells. They're coated with sugar on them.
Mm,
Right. So we call them bad carbs, right? Because they are bacteria associated, and those carbohydrates are very specific to Bordetella pertussis, the bacteria that cause the infection. They're different from our human carbohydrate structure.
mm,
So because they're on this bacterial surface, so we think if you generate a good immune response against those immune response can kill the bacteria directly. In the
mm,
lab, we actually have data to show that's indeed the case. We test in animals with a prototype our vaccine, generate immune responses. Those immune responses, and usually antibodies, can kill the bacteria, can recognize bacteria and kill the bacteria.
wow.
So, so with the newer research, what we want to do is, we're not saying second generation is bad. We try to combine, right, the second generation with our newer vaccine. Second generation can help alleviate the symptoms. Newer vaccine can kill the bacteria. So put this one two punch together. We think that would be more effective in reducing the whooping cough.
Yeah, and so not only would, say I were to receive this third generation vaccine, I would be okay. I would survive if I contracted whooping cough, but at the same time, I'm not going to pass it along to other people, which is kind of the issue that you guys are targeting right now.
Yeah, absolutely. That's right.
And I mean, I know we're simplifying this a lot. Research like this, I mean, what does a timeline look like for potentially, having something like a third generation vaccination? Is that something that, is still years away from us at this point?
Yeah, so the vaccine development process, typical ones, is very long process because we start with making the compound in the laboratory, right? And once we make the construct, we want to test on animals, make sure that's safe, efficacious in the
Hmm.
animal models, and then we will carry out clinical trials on humans, right? So, and also want to do a smaller scale testing first, make sure that's absolutely safe because we are immunizing healthy people. So, want to show that the side effects are minimum for this, right? And then it goes to larger scale clinical trial on large population. And if that's been shown to be efficacious, to be safe, and then finally that will be approved. So typical process will take at least 10 years
Yeah.
to develop that process. So it's a very long process because the safety is very important, efficacy is very important. We really want to demonstrate that that's all correct before that be applied, used on humans.
Yeah, absolutely. And I know you mentioned, part of the push behind this third generation is the fact that we have seen this relatively recent increase in whooping cough infection. The ultimate goal is that, once we could see, potentially this third generation, that hopefully we would decline numbers of infection.
Yeah, that's absolutely right. Yeah, that's the goal for our
That's the
study. Yeah,
goal.
yeah,
That's the goal.
yeah, yeah.
Anything else about this you'd like to mention? Anything else you think is of interest to people or worth explaining? I know it's a very complex topic that we're really, simmering down here, but I think it's, important for people to understand what you guys are working on and what this could enable, for everybody potentially one day.
Yeah. I just want to emphasize that, especially with the current environment, vaccines do work, especially, the whooping cough case. We've seen that. If you just look at the numbers in the history, look at the incidence rate, right? In the 1930s, 40s in the US, we have 200,000 kids die
Mm.
from whooping cough infection. And as soon as that the vaccine become available, that rate dropped significantly, and less than 1% of what was the death rate before. Right. So we have a good way, a good vaccine that can significantly reduce this, and we want to keep it that way. But right now, there's some little bit issue with the newer vaccine in terms of efficacy, right? So we want to address those problems, and then need a lot of investment in research, right, to develop newer generation vaccine. I think that's where we're worth it for the public support towards the vaccine studies and research.